Problem 2. The two circles pictured have the same center C. Chord AD is tangent to the inner circle at B. AC is 10 and chord AD has length 16. What is the area between the two circles? Let's reread the problem. We know that chord AD is tangent to the inner circle at B. So, tangent means that it only intersects the circle at one point. And for every single point on a circle, there is only one tangent line, because once you shift even a little bit, it's going to intersect with at least one more point. So tangent is a concept to become more familiar with, especially as we move into competition geometry math. Another rule to keep in mind is that the line segment from the center of the circle to the point in which the tangent line intersects the circle is always perpendicular. So this will happen for any other tangent line here. For example, here it would also be a 90-degree angle. This is a rule to memorize when you solve problems with tangents. So here, as you can see, a right angle is already labeled out. And let's continue reading the problem. AC is 10. And chord AD has a length of 16. So we know that this entire thing is 16. What is the area between these two circles? This is a lot to take in right now. So what I like to do is always think backwards. So another tip I have is to think backwards. Because once you think, oh, what do I need in order to solve this, which I need to solve this, like it immediately guides you and you know where to start. So let's think about what we are trying to find. We're trying to find the area between the two circles. So this entire portion in here. Well, in order to find that, we need two things. We need the area of the small circle and the area of the large circle. All we have to do after that is subtract. So how can we find the area of the large circle? So we're going to call this the large circle. And let me put that in black. The formula to find the area of a circle is area is equal to r squared, radius squared, times pi. Do we know the radius of the large circle? Well, we have CD and CA, which are the radiuses, and we know that they have lengths of 10. So all we have to do is 10 squared times pi, giving us 100 pi. So this is the area of the large circle. What about the small circle? Well, in order to find the area of the small circle, we need its radius first, right? But what is its radius? Well, the radius here, I'll mark it out, is x. It's CB, but we don't know what is the length of CB just yet. So how can we find CB? Well, you'll start to observe that here we have two right triangles. So whenever we see a right triangles, the first thing that should come up to mind is the Pythagorean theorem. How can we use the Pythagorean theorem to solve for x? Well, we can use the Pythagorean theorem to solve for a side of a right triangle whenever we know two of the other sides. Here we do know one length of CA, which is the hypotenuse. We should also be able to find AB because 16 divided by 2 is equal to 8. So we can find x by saying x squared plus 64 is equal to 100. That means x is equal to 6. So we know that the radius of the small circle is 6. Now we can apply that into this formula here, which is 6 squared pi is equal to 36 pi. So the area of the small circle is 36 pi. And remember, now that we have the area of the two circles, we need to find their difference. So 100 pi minus 36 pi is equal to 64 pi. Therefore, 64 pi is our final answer.